In 8.2, we're going to look at solving quadratic equations again. Now, we've done quadratic equations in the past. As an example, we've looked at something like x squared plus 3x minus 28. And we want to make sure that these quadratic equations already equal 0, which this one does. What we did in the past back in chapter, I want to say 6, was we said, okay, well, if it equals 0, we can just go ahead and factor. And what you found out using AC method was, or trial and error, was that this thing factors out into an x plus 7 and an x minus 4. And then we said, okay, now how do you actually solve this? You would set both pieces equal to 0, and x plus 7 would get set equal to 0, and the x minus 4 would get set equal to 0. And you'd get x equals, well, we'd subtract the 7 from both sides, and that would give you your first solution of negative 7. And on the other equation, we would add the 4 to both sides, and that would give us x equals positive 4, and we ended up with two solutions. We ended up with the solutions negative 7 and positive 4. This is wonderful and great. The problem is, what if it doesn't factor? That is a huge problem. If something doesn't factor, then we need something really strong. It's called the quadratic formula. The quadratic formula, think about factoring as a tiny hammer. It works really nice sometimes if you have something that's nice and cute and easily predictable that you can factor. Your quadratic formula is your sledgehammer. It's always going to work. It's a little messy and it's not pretty, but it does work. So hopefully the goal is, if you have a quadratic equation like this, we want it to equal 0. Once it does, hopefully maybe it factors. If it doesn't, we're stuck with the quadratic formula. Now, I'll have students who sometimes ask, well, can I always use the quadratic formula? And I say, yes, it's our sledgehammer. It will always work. Then why don't we always use it? Because it's a pain. We don't want to always do that. And sometimes in some problems that aren't quadratic formulas that we actually need to solve, we will still need to actually factor something out. So we don't want to forget or unteach ourselves or unlearn how to factor either. So, but what I'd like to do is redo the problem we just did using the quadratic formula. The quadratic formula is up here and it's in your notes. I would memorize this. You will never be given this on a test as a formula. You will always have to memorize it. If you're one of those people who has trouble memorizing, what I would do is I would go to YouTube and search quadratic formula songs and find one that you find particularly annoying and play that several times a day. Why do I say one that you find particularly annoying? Studies have shown that if you find something irritating, you'll actually probably remember it more or better. And the problem with this formula is it is so detailed. If you get one small part of it memorized incorrectly, it throws off your entire answer and you will not get the correct answer. So I highly, highly, highly recommend you finding a song that really bugs you and just play it several times a day until it is stuck in your head. I do know that there's a version of the quadratic formula done to the Addams Family theme song, just to give you an idea. Feel free to look that up on YouTube. So let's redo this first example that I did using the quadratic formula. Notice the quadratic formula starts out with x's, because we're solving for x in our equation, is negative b plus or minus. Notice the plus or minus, what that is there for is to make sure that we end up with two solutions, most likely. The square root of b squared minus 4ac all over 2a. Well, what are these a, b, and c? Well, a is what's ever in front of the x squared term. And if you don't see a number, it's just like when we did AC method. It's whatever's in front of the x squared term, which if there's nothing there, it's a 1. Our b on this one is just the number positive 3. And our c here is a negative 28. So let's go ahead and plug these in. So the first thing that we've got is that we're going to plug in our b. Well, and again, there is a negative out in front, so we'll actually put we'll actually have a negative in front of our b, which was 3. Plus or minus the square root of, well, we said that b here was 3. So the 3 squared would actually be 9. Minus 4 times your a. We said that a was 1. So we can replace this a here with 1. Times c. Well, we said c was, let's see, what did we say c was? C is going to get plugged in here, which we said was negative 28. So we can plug that in. And that's all underneath your square root. All over 2 times, again, our a on the bottom was, our a was 1. So let's see, and continue along. So that negative 3 out in front is going to stay there for a little bit. We can go ahead and simplify the bottom because it's pretty straightforward. It's just a 2 times 1, which is just 2. Let's see, what about our square root, though? Our square root, you still have to follow the order of operations and do the multiplication first. So we have a 4 times a 1 times a negative 28. And it also has a negative. So a negative times a negative is going to turn into a positive. Well, what's the 4 times the 1 times the 28? Well, the 4 times 1 times 28 will give us 112. And again, remember, a negative times a negative gave us a positive 112. This 9 here will stay the same. So then we just have a inside of our root, we have the square root of whatever, let's see, what do we have 9 plus 112 is? Well, 9 plus 112 is actually 121. And what's awesome about 121 is we can take the square root of it nicely. It comes out cleanly. The square root of 121 is just 11. So now we actually have to use our formula here to come up with our 2 answers. The first answer we're going to look at is the one that gets made up by using the plus here. The first one is negative 3 plus 11 over 2. Well, negative 3 plus 11 is actually going to give you a positive 8. Over 2 will just give you 4. So that's your first answer. Your second answer is going to have you using, instead of the plus, the minus sign. So that's going to be having me look at the negative 3 minus 11 over 2. Well, negative 3 minus 11 will give us negative 12. Divided by 2, negative 3 minus 11 will give us negative 14. Divided by the 2 will give us negative 7. So we got 2 answers just like before. What were our 2 answers? We got 4 and negative 7, just like we did before. From factoring, it was just a whole lot more work. So moral of the story, if we can factor, we want to, but the quadratic formula does always work. So it's a very valuable tool for us to know and understand.